started. First of all, it's exciting to be here. Thank you for coming. We have a few speakers for you today. We're going to talk about the Google Visualization API. My name is Nir Bar-Lev. I'm the product manager for the product. We also have Yoav Bar-David. He's the engineering lead. He'll take you into a deep dive of the Google Visualization API. And we're also excited to have two speakers from partners who've developed products over the API already. We have Yariv Ben-Tovim from Panorama and Chris Nye from ViewPath, who will also share with you their experience with working over the API. So we hope we'll give you a clear picture of everything around the API. Why don't we get started? So this is basically the agenda for today. One thing that I'm really excited about is part of what we're going to talk about today is new. It's been up only for 24 hours on the website. These are the red things marked as new. But the overview that we'll give will go over everything that we have today, so we won't stop at each time and tell you this is a new thing or not. You'll get a clear overview of everything that's going on. I'll give you a background of the API, what we're trying to accomplish with it, what is it good for. Then Yoav will take you into a deep dive. That's the main part of the session, into creating data tables for the API, looking into creating visualizations, using events. We'll look at the query language and creating queries, and how to create gadgets from these visualizations. And then we'll have the two case studies I mentioned with Panorama and ViewPath. So what are we trying to do with the Visualization API? Visualizations, there's tons of different kinds of visualizations. I think we all are aware of those and know those. There are the generic visualizations like the pie chart or the line chart. Then there are very specific visualizations, like this is a visualization, right? Even think of your two-handed clock. That's a visualization for time. So there's visualizations for very specific things. There are also easy visualizations, right? A table is an easy visualization in many ways. It's easy to create. It's easy to use. There are visualizations that are hard to make. This is, for example, the motion chart from the Gapminder organization, which Google acquired about a year ago. It gives great insights into looking into complex data over time, but of course it's a hard visualization to create or even feed data into. And of course I can go on the different types of visualizations. There are many ways that you can look at different visualizations. There's tons of options. And what are we trying to do with the Visualization API? Well, the problem is that you've got tons of options. You've got many ways to visualize data. You've got lots of data sources, right? You have anything from CSV files to SQL databases, anything in between. And there's different types of applications you want to embed those in. And each time you want to embed a visualization, you basically go out and find a specific visualization package, and you have to integrate with that. And if you guys have done that, you know it's a whole project on top of the original project or product that you're doing. And that takes time. And then you're limited to that specific package, and you can't use anything else that's out there. So there's too many APIs, too many packages. There's too much work for developers. We want to make things fast and easy so we can focus on what we're trying to do. So this is where the Visualization API comes into play. We're trying to create a one-stop shop for visualizations over the web. And I think what we'll do right now is I'll bring up Yoav to show you how we're actually going to do that. So Yoav?
Okay, so actually when we're talking about structured data visualization, there are two layers here. One is how do I get the data? And the second thing is how do I visualize it? So let's focus on first on the how do I visualize the data, assuming that I have the data already somewhere. So what we're trying to do is, first of all, create a single API. One API that once you learn it, you can visualize with it any type of data, or almost any type, because data can go way complex. But we're trying to target almost any type of data. And we're trying to create an API that is not only good for Google visualizations. It can be good for anybody. Anybody can create another type of visualization on top of that, on top of our API. And we're also trying to create a single directory where everybody can come in and find any visualization, ideally, anything that is out there. So we're focusing now on the top part of this. single API for visualizations, multiple instances of actual visualizations. So the first thing to do is kind of abstract what is a visualization. And the general abstraction is that it has 3 components. The data you want to show, how do you want to show it, options that control how you want to show it, and where do you want to put it on a page. So the data is something that we can generalize. We can say, okay, this is how you represent data. Options are very, very specific to visualizations. A pie chart can have an option if it's 3D or 2D. This may not be applicable for, a clock. So, but there is a way to abstract options in a generic way. And the last thing is where you want to put it on a page. We're talking about visualizations in web pages. So basically where you want to put it on a page is a DOM element where you want to put it in. So this is kind of an abstract visualization. Let's do a deep dive and see every one of those components. So how do you represent the data? We try to find a way that is common for almost all the data visualizations and still easy to learn and understand. And the best metaphor that is out there is a 2-dimensional table. It's a table that has rows and columns. Every column has a data type. Rows have values. The cells are intersections of rows and columns. Something very basic that everybody knows how to work for. This is something very similar to what you get out of a database. Every column can have a data type, a label, which is typically something displayed to the user, and an identifier, which is typically internal only. And we'll see the use of that later. Every cell has a few properties that are common. So all the data must support that. One is a value, and that depends on the data type. If it's a number, it's a number. If it's a string, then the value is a string. The second is a formatted value. We see that it is a common issue for visualizations to show a value, not the underlying value, but the value formatted somehow. So you may have a data object, but you want to show it formatted by the user's locale or other kind of specific things you want to show the data as. So every cell has a formatted value. You don't have to put it there, but every cell has that property. And then there are additional properties of cells that depends on the data source and on the specific visualization. So here's an example how I created a data table. There's a class called Google Visualization Data Table. I add columns. One is a string, one is a number. I add 3 rows, and I put in values in this data table. Notice that for the numbers, there is also a formatted value. It's optional. And the data types we currently support are number, Boolean, date, datetime, which is a date and a time, and time of day, which is just the time part of a date and time. So this is basically how I create a data table. And the idea is that if I know how to create a data table, I can use any visualization on top of this data. Some may not make sense, but any visualization that makes sense on top of this data table. So we have the data. Now, how do we create a visualization? So it's 2 parts. There is a constructor. I create a new instance of Google Visualization Pie Chart. This is the constructor of a pie chart, and give it a DOM element, which is the container. And this is common to all the visualizations, Google's or non-Google's. There is a constructor with a single parameter, which is a container element. And then there are the options. Options is a map, a name-value map, and that's a contract between the specific visualization and the developer. In this case, the pie chart has options like is 3D, legend position, and I call it draw method. The draw method has, again, the contract is 2 parameters. Data, a data table, and options, a map. That's all I need to know to create a visualization. So let's see for just an example how this looks like. So the first example here is I created a data table with some names and name, manager, salary, and I create a new instance of the table visualization. The table basically is an HTML table, and I call it draw method. The output of this is a table and that it has some hover thing and selection, but basically a table that shows all my data values. If we go see another example like this, then in this example I created the same data table, and then I create on top of it a pie chart using the same constructor and the same draw method. And I also created a column chart on the same data table. If I look at the output of this, then I get the pie chart and the column chart based on the same data table. Now, in this specific case, those visualizations are rendered as vector graphics. So they have some interaction. When you stand on top of a slice, you can see it's highlighted, or you can click here to get a tooltip, or you can click here to move a pie slice. That's a package of a pie chart. There may be other packages of pie charts that use the same API and give you different functionality. And if you want to switch from this pie chart to a different pie chart, you just change the name of the class. That's all you need to do. And in this case, it's bar charts. Now, so far we've seen how to create a data table, how to create a visualization. These things can also be interactive. So I can draw something, and then I can change the data. In this case, I'm adding a row, putting some values there. Let's see an example, a real code example to see how it looks like. So here I have a visualization of, I'll go scroll a little up, a visualization of an org chart. There's a table saying name and manager and an org chart. And here I have a function called hire Joe, which adds one row, adds a value of Joe, reporting to Roger, and drawing again the same visualization. So if we look at how this looks like, so we have something on the screen, the original org chart. I can click hire Joe, and Joe is added here. I can promote Joe, and if he's not doing a good job, I can fire Joe, just like that. Sorry. Okay, so we can interact with the visualization. Visualization can also trigger events or listen to events. And this is something we see very common. I mean, you want to show something on the screen, but you also want to make it live in some sense, that people can interact with it. And so one way is to communicate between visualizations, and another way between the specific visualization and the container page. And the way to do it is very similar to how you handle other interactions in JavaScript. There is an event model. A visualization can trigger an event, and the page can listen on events thrown by visualizations. So this is a very generic thing. Every visualization can support their own event. But we're trying to find the common use of events, what is common to all the visualizations, and kind of standardize it. And the first event that we standardize is the select event. It's a very common thing that user can select something on the screen on what they see. And so we defined an event which have a specific name, the select event. And to support it, to support selection, you have to do three things. One is trigger the select event from your code. It doesn't have to be your code. You can use a visualization already out there that supports the select event. You support a method called getSelection, which returns the selection, and you support a method setSelection, which sets the selection. The interesting part here is that the selection is not about user interface elements. It's not about a slice in a pie chart. It's not about a column in a table. It's about the data. So if I take a data table and pass it to a pie chart, and the user clicks on a pie chart, the selection is about the user selected this row or this column or these cells in a pie chart. So in a sense, you don't have to know anything about how the output is rendered. You only have to know about things that happen on the data level. So I'll go to a live example here. In this case, I have another data table, and I'm showing it as two things. One is a table, and the second thing is an org chart. And what I do here is I tell that I'm listening on the select event from the table, and basically when it fires, I just get the selection from the table and set it on the org chart. These two were developed by two different developers. They don't have any agreement between them except for the select event semantics. And I'm doing the opposite way too. I mean, I'm taking the select event on the org chart, getting the selection from the org chart, and passing it to the table. So if we look at how this looks like, I have a table, and the same data rendered as an org chart. And once I click on a row here, the row is highlighted in the org chart. I can click on the org chart, and the table highlights the same row. So in this case, they are synchronized, but just 2 lines of code. How do we load the API? So we designed this to be open for Google visualizations, but also for third parties. So for Google visualizations, we're using the same API loader. You load the visualization API, version 1, and give the packages that you want to use. There are a list, and I'll go through the gallery in a second, but there are a list of visualizations that we already support as Google visualizations. If you want to use a third party, you include their JavaScript code, maybe style sheets, load the visualization API, and from there on, you're the same. You create a new instance of a specific visualization, load your data, and call the draw method. All work the same. So gallery, we loaded quite a few visualizations. Actually, it's nicer to show visualizations not as text, but as small images. So these are the visualizations that we already loaded and anybody can use now. It's an annotated timeline series, which you can see in Google, used in Google Finance. All kinds of lines and bar charts, gauges, heat map. Each one of them comes with its own code example. You can see how to use it. And basically, you have to learn just the name of the constructor and the data type that is expected by the specific visualization. So the next part is how do you write your own visualization? There are a lot of things that Google supplies, but if you want something on your own, how do you do that? If you want to start with the simplest thing, you create a class, and this is called as myChart. You have a constructor that gets a container element, and the typical thing to do is just save it on this context. And you provide a draw method that gets a data table and gets an options map. And you do whatever you need to do there to draw the visualization. It can be in Flash, it can be vector graphics, it can be HTML, it can go to a server and render an image. It can do anything that you want to display that data table. If you want to support selection, then you need to trigger the select event whenever that means something from your specific code. You need to support the get selection method. Get selection returns an array of objects. Each object has properties of row and column. You can specify only a row, only a column, or both. And again, those are the data table row and column. And support a set selection, which the same thing. You get an array of objects. Each one can have a row and column properties, and you show what is selected on your screen. Once you created your visualization, how do you publish it? How do you make it available for other people? So a few things to remember is, first of all, is a namespace. Since these JavaScript snippets can go into a single page, you want to prevent namespace conflicts. It's on the JavaScript class name, on the CSS names. So make sure everything is has some kind of a fully qualified name that is unique. You need to host your file somewhere, JavaScript, CSS, images, anything that you need. And Google has a lot of solutions where to host this, including on codegoogle.com. You create a documentation, basically shows a description, code examples. You define the data structure that you expect. Some visualizations can support anything, like an HTML table. Some are very specific, like a pie chart needs to have two columns. One is a string, which is a label, and the second is a number, which is the value. And if you give it something else, it probably don't know what to do with that. And the last thing is define your data policy. What do you do with the data? Some visualizations, the data stays on the client. Nothing goes out to any server, so people can kind of safely use that. Some of them need to send a request to a server to draw an image. Some of them need to send the data to a server to do some processing. You have to very explicitly define what is your data policy, what happens with your data. People want to include your JavaScript code on their page. You want to know it's safe, or what are the implications of showing the data through your visualizations. And the last thing, you can go and submit it to our gallery. Actually, we didn't open the gallery yet. We're going to open it in the next few days to submit your own visualizations into that gallery. So far we talked about, you have the data on the client and you want to visualize it. Now, how do you get the data to the client? How did the data get there? So this focuses on the data layer part. And what we're trying to do here is, again, create a single API that you can bring data from multiple data sources and bring the data in a common way, in a common format, in the same data table format that the visualizations can take and draw. So typical data sources can be databases. It can be in files like CSV files. It can be online in applications like Google Spreadsheets, web services. There is a lot of data out there. And we're trying to create a single API to get all that data into visualizations. Currently, we support only Google Spreadsheets. That was already launched about 3 months ago. And we'll see a few examples of how that works. But from the developer side, you need to create a query. You need to create a query object. And the query gets a single parameter, which is the data source URL. It's a URL that if you access a server with that URL, you will get the data as a data table format. Optionally, you can set some query modifiers on top of that query object. And we'll see a little bit about what are those query modifiers. The idea here is that we want to push to the server as much data operations as possible and do the least amount of data processing on the client. And then you set a callback, you send the query with a callback function. The callback function is get called when the data arrives. Typically, you check if it's an error, you show some error message. And if it's OK, you can just call the visualization to display that data. Query language. The query language is very similar to SQL. If you know SQL, you'll probably know very quickly to use this language. There are clauses that you know from probably know from SQL, like select, from, where. It looks very similar. There are a few clauses here that we added that are targeted specifically for visualizations. Things that we saw that are very common use cases, and SQL was not designed to bring the data to a user viewable thing. It was designed to bring the data to a program. So we have the label clause, which some SQL implementations have something similar. But basically, in the data table, every column has a label. And typically, visualization take that label and use it as something that users can see. If it's a table, it can be the table header. If it's a pie chart, it can be a label and a pie chart. So in this case, you can take a column ID and give it a different label. There is the format clause. We want to do all the data formatting on the server. If it's number formats, date formats, all kinds of other formats, do it on the server. So you can have a format clause and saying, OK, I have this number value. I want to format it as a string with a $sign and commas and 2 decimal digits. And there's the pivot clause. Basically, what pivot does is take unique values in a column, like the year 2005, 6, and 7, and convert each value to a column. So we'll have a column of 2005, 6, and 7. And we saw that this is a very common use case in visualizations. For example, if you take a bar chart and you want to have different colors for different bars of different data series, then bar chart packages typically do that. They take values, they extract them, they create new columns. We wanted to give this functionality already on the server side so the data can be transferred to exactly as the visualization expects it to be. So that's a pivot operation. The roadmap for the data source interface is to add additional data sources. As I said, we only support currently Google Spreadsheets. And we want to enhance the query language. That are 2 things that we have on our roadmap. The next thing is visualization gadgets. So far, we took some JavaScript, we created the data locally, or maybe we brought it from a Google Spreadsheet, and we displayed it on our web page. Now, we want to create also visualization gadgets. There are a few reasons why we want to use gadgets. The first reason is related to security. And if you want, there are some applications that in your web page, you can show whatever data you want. But in a generic application like Google Spreadsheets, we can't just embed JavaScript code from anyone out there into the web page. The way to solve this is by creating visualization gadgets. Such a gadget basically is a gadget that has a data table and it displays it, and it sends a query to get the data. And the place where to get the data from, the query data source URL, is a soft configuration. It's a gadget preference. So if you have a gadget that does a pie chart, and all you need to do is put a URL that says, OK, bring the data from there and draw a pie chart, then this gadget can run on a Google Spreadsheet or any other application in a safe mode. It's isolated from the underlying page because gadgets run in their own iframes and are isolated from any access to the JavaScript of the containing page. If you have a visualization gadget, other things you can do is you can syndicate it. You can send it to other people very easily. You can go to iGoogle. You can add it. First of all, you can add it to any gadget container. You can add it to iGoogle or to any other gadget container application. You can send it to a friend, and it just sends a link, a button that you click on it, and they add it. And in a sense, when somebody else adds the gadget, it's already configured with the same data source URL that you had. So when the gadget is loaded, it sends a request to the spreadsheet, brings the data, and displays it on the web page. You can take a gadget and embed it as an iframe in any web page that you have. And before I show you the code, let's see just an example how this looks like. So here I have Google Spreadsheets open, and I created a very simple table of calories per, I don't know if to call it a fruit or vegetables, but I just select the range here, and I go and insert a gadget. And I get a directory of gadgets. Some of them were developed by Google, but some of them were developed by other companies. And I can add a gadget that was developed by somebody else. In this case, it's a fancy bar chart with images. And I can display it as chocolate bars inside a spreadsheet. And I get this kind of a bar chart inside my spreadsheet. Now, this was not developed by Google. There is a way that whenever I update my spreadsheet, there is an event sent to this gadget, and the gadget reloads the data and displays it again. So it's tightly connected to the spreadsheet, and yet it's visualizations that are coming from third parties. And I think this is a very powerful concept of people adding new types of data visualizations on top of an online spreadsheet. And I can take this gadget, and with just one click, add it to my iGoogle page. And it's there, it's configured to access the data. Whenever I change the spreadsheet, whenever I open the iGoogle page, it will get the real-time data, the latest data from the spreadsheet, and display it here. So how do you write such a gadget? There is a class called a gadget helper, which does basically two things for you. One is it can create a query object from the gadget preferences. You can do it yourself, but this is a kind of a convenience method. You give it the gadget preference, it creates a query object that is configured with two things, the data source URL and the refresh rate. How often do you want to refresh? And when you get a response, there is a method called validate response. You call it, if there is an error, it shows an error in the gadget top left corner exactly with the details of the error. If everything is okay, you just continue and do your visualization out there. We have a bunch of gadgets already in the gadget gallery, and the gadget gallery can be found in two places. One is if you go to our code page, there is a gadget gallery here. You can see the list of all the gadgets. Some of them again by Google, some of them by third parties. Some of those third parties here, and we'll talk about their implementation experience. There are very nice things like a Gantt chart and pivot tables and a translation gadget and all kinds of fancy things there in the gadget, and people are adding continuously new visualization gadgets to this gallery. The second way is if you go to to a spreadsheet here and just insert gadget, and the same gallery is integrated, almost the same gallery is integrated into the spreadsheet. You can select here directly from the spreadsheet the type of way you want to visualize your data. Okay, so the next part is we have two partners here that developed gadgets on top of Google Spreadsheets. The first one is Panorama, a company that developed a very sophisticated data analysis, data pivoting gadget, and in a sense added a new capability to Google Spreadsheets that was not developed by Google. So we have Yariv here from Panorama. Hi.
Hi, everyone. Thanks, Joach. It doesn't work? Okay. What I wanted to share with you today is what value Panorama was able to provide to our customers and to you guys through the visualization API, and tell you a bit about the experience we had with it. Just a couple words about Panorama. Panorama is one of the leaders in the world of business intelligence, supplying many customers ranging from medium to enterprise customers the ability to optimize their business through different visualization, different capabilities such as analyzing, finding trends, finding exceptions, and hidden information within their data. Our customers come from different industries such as manufacturing, financial services, retail, media, and so on. We have customers all over the world. Some names are Harley-Davidson or Coke and many others. Panorama was looking for a smart and easy way to add visualization of spreadsheet data into the Google Spreadsheets. The solution we found was through the visualization API. I want to share with you some of the value that we see in the visualization APIs. The first thing is the framework that we have through the gadgets. It allows us persistence of some information. It allows us the security management. We don't have to handle it ourselves. And it also provides us the whole container environment. Through the same environment, we also are able to provide collaboration. You can put the same gadget, or you develop the gadget once, and you could put it either on the spreadsheet or on iGoogle and some other places, or host it on other pages. We found the visualization API very easy to use. It supplies us good performance. It's easy and fast to connect to different spreadsheets data. And, well, in the future at least, it's going to be a zero effort to connect to any other data sources. It also gave us the ability to live inside the Google applications, the Google apps, which is very strong. And the last thing here, through this integration that we created, we were able to extend our capabilities, to extend our suite of products, and supply an option of connecting and visualizing, supplying a pivot table on top of different data sources that come in the shape of a tabular data. Some problems we had before the new visualization API. We had issues with performance. The XML response was too large. It was hard to process that XML response. We had to manually handle the response. It was even different between Firefox and Internet Explorer, so it's just cumbersome to work with it. We had missing information about the spreadsheet content. We couldn't know what the data type is. We couldn't know if it's a number, if it's a date, or a string. The power of the visualization API. The different things that are supplied with the visualization API is, for example, the ability to select the range. You just go into a spreadsheet, you select the range that you want to present, you add the gadget, and it's already inside the framework in the container, the ability to select the range or the parameters that we get into the gadget. It's easy to listen to the different spreadsheet events, as you've seen before, just to listen to the update events. Today, there's, as you've seen, again, you've seen the object model that you can use to process the data, which is much easier. The fast query response is a great improvement, and we do get very descriptive information about the different spreadsheet content. This is really important today when you try to create a pivot table on top of your data. You need to know if you can aggregate the numbers, if the numbers are numbers, or are these columns that you want to present as headers, for example. And the code is really simple. I mean, it was really easy to create this, and you're going to see that in a second. I mean, this is just as much as we needed, or almost everything that we needed to create the visualization. Of course, we initialized the connection. We initialized the Google, and we're listening to the handle query response. We did use the gadget helper to make it easier for us. We create the query from the preferences or from the parameters that we get when we initialize the component. We validate the response, and then we just get the data table and start working on the data table. There are a few points that we do think should be improved or should be included further. The ability to identify the user. Once a user goes into a gadget in one place, we want to be able to know that it's the same user on another place. That management can be done by yourself, but it would be better to get that with the gadget. The ability to connect between different gadgets is, as we've seen, just was added right now. It's a new thing, and it's great because it will allow us to do those interactive pages, selecting one thing on our pivot table, seeing the result on a chart, for example. The ability to connect the queries to other data sources, not just the spreadsheet, that's going to be really helpful for us. A bit more control on the range selection if you want to change it, if you want to select from different sheets. The ability to detect the container of the gadget. We want to present different information or present the data in a different way depending on the container, if we are inside an iGoogle page or if we are on a spreadsheet. And the last thing here that we found that we need is the ability to resize the control programmatically. Today, in iGoogle, you can select the initial height, but you can't change it. And when you're inside a spreadsheet, this is really a fixed size that you can't change, and we find it missing. I think later you'll be able to come and see our gadget in the booth and ask more questions. Guys? Thank you.
So we have Chris. One thing I wanted to say is, I don't know if it was fair. We launched a lot of changes yesterday with the event model and everything, and both Chris and Yariv worked on the earlier version. Some of the things that they've asked for were implemented. So it's interesting to actually see how things have changed. Please.
Thank you, Nir. I'm Chris Nye, Chief Architect at viewpath.com, and we, as you said, about a month or two ago, we started developing a Gantt Gadget using the visualization API. Back then, the visualization API, it only worked with the actual spreadsheets. We'd put the gadget in the spreadsheet. Since then, it's been extended quite a bit to actually run outside it. So ViewPath is we have an online AJAX-based project management application that is already based on modules and components. So we have the Gantt component up here as part of the application. And what we wanted to do was take that out of the application and make it available to someone whose data might be in a spreadsheet with Google Docs. So first, since we already had the gadget, we had to decide whether or not we were going to write it from scratch or to reuse our code. We decided to actually reuse the code so we get a faster development time and be able to share common features and functionality between it, and ultimately a smaller code base to have to maintain in the future. So here it is. So what I actually want to talk about, some of what I want to talk about has been a little bit obsolete by the changes, the rapid changes Joe has been making to visualization. It's really kind of exciting. Oh, you can't see the color in that. Well, it looks like I'm missing. Sorry, bear with me. It looks like I'm missing the color on that, but a basic visualization gadget. If you're going to write a basic visualization gadget, it looks kind of like this, and you're structured into basically 3 different types of code, kind of following the model view controller paradigm. I call it model view loader. You have the model code, which represents your domain-specific data, possibly structured in a format that is convenient for your visualization. For our purposes, we already had a model. We already had a recursive sort of hierarchy of tasks that had name, start, and finish that we expected. So for some people, though, they won't need their own separate model. They may consume, as Yoa showed, they may consume the data table directly. And that's appropriate for a lot of different things. But sometimes you're going to want to have some accessor methods or some helper methods or maybe some of your own validation code. Or you just already have your model like we did. So in this particular example, I show the class would take a response and can load itself from that. Now, ideally, if there's no response, or if it will load some test data. So if you're just using a page without it, you can just fill up some test data and not have to connect to the response. Anyway, so the view code, of course, represents it takes the input model and it's just going to render stuff out to an output element. For mine here, it's just a method, but of course the new model with the latest changes to Google Visualization is to actually have a visualization component. Then the loader code is, as Yoa showed, the code that's going to actually take the data out of the spreadsheet and put it, create your model, populate with the data, and then actually call the view function. So what we're going to do here, you have your model and your view, and it's just embedded right in the gadget. but it's not reusable somewhere else, like into a standalone visualization page. So what we're going to do is we're going to extract the code. We just use a server-side include here to extract the model and the view code out into a separate file. This is probably a no-brainer for lots of you. So the advantage then is when you go to make a visualization page, one that stands alone, then it can just use the same code. And here we can just include it with a source script command. All right. Furthermore, then, if you're actually going to, and this final example is of an offline test page, and this is if you're going to actually have, if you want to load it with your own data, maybe you have your own model, you want to load it with your own data and just test it. Offline, you don't actually have to be able to connect up to a spreadsheet or something else to actually get the data. And actually, as I said, the API has changed quite a bit. We used to only be able to only load the data, it was only read-only from the data table, but now you can actually sort of write to the data table yourself, and you can fill it up and populate it yourself. So, anyways, in this sample page, just when it loads, it includes it. When it loads, it creates a new model, which is just going to generate test data. You do it yourself, and then you just draw the view. The reason I'm showing these is that if you're going to go about writing in a visualization gadget, when you actually have the gadget, there's a lot of dependencies to actually have the gadget running. You have to have a spreadsheet created. You have to actually be serving up the gadget locally, and then you'll put in the URL. It has to connect back. It means you have to have your firewall open, your service up, generate an XML, and then it's going to be coming up in a little iframe. So there's a lot of dependencies that actually have to be working in order for that to work. But if you actually author it this way, you can actually have an offline test page and do most of your development there locally, and you can just refresh it and see changes right away. When you're using a gadget and it's an iframe, sometimes it's a little harder to actually see changes or force it to refresh. Or the browser will be caching some of your resource files, and it's kind of hard to actually force it to sort of reload those when it's an iframe. So if you're making a gadget, I highly recommend it. And now, as you showed, the actual hello world of the visualization actually shows to kind of do it that way, to actually just make it as a visualization page first, and then go after that and kind of add in the extra support of allowing it to load as a visualization gadget. So that's all I have.
Okay, that's it. More information, you can go to code.google.com APIs visualization, and we'll open it up for Q&A. Please use the mics and speak to the mic, so we're recording this so you can be heard.
What about 3D? What do you guys have been doing on the 3D front?
You want to take that?
Can you repeat the question?
So the question is, when do we support 3D visualizations?
Well, the API is about transferring the data to somebody who can visualize the data. Anyone can, if somebody is going to write tomorrow a 3D visualization, we support that. If you're asking when is Google going to add a specific 3D visualization, I can't give you any kind of a time or a specific thing. There are like the semi-3D bar charts and line charts if you want to do something that you can zoom in and out and all that. 3D on a browser is hard to do. It's not easy to do. You can do that in Flash. You can do that through plugins, but I don't know.
I'll challenge everyone here to contribute and add so
Yes.
everyone else can enjoy it. We'll be really happy. This is something for the community. Let's take it one.
So the data access, I mean, the visualization part of it, it's really the story you have about one API is good. With the data access right now, it's either hard-coded or a spreadsheet. Is that what I understood in the presentation right now? And if I want a source of data, I get it hard-coded or I do it on top of Google Spreadsheet.
So there's, let me see if I understand the question.
Was that a fair characterization? Or?
So let me just repeat the question.
Okay.
So you're asking if server-side data sources is just spreadsheets. Is that?
It sounds like it right now.
Yes. So right now, you can either use the JavaScript flavor of the API and then create your own data table on the browser, or for server-side data sources, it's only Google Spreadsheet. However, we do plan to add more data sources.
So what I guess I was going to ask is like a middle ground would be right away, you could do fairly quickly, I think, is to support like an API to take like a RESTful request to return either JSON or XML and populate the table. That would make it like I could have any data source I want, and once I made a web service API that returned JSON or XML tabular data, you could, I mean, obviously I could write the JavaScript myself to do that. I could write JavaScript, make the AJAX call, get the data structure, and then write it in via JavaScript. But I mean, that seems like an obvious helper routine you could do, and that would make it a lot of data sources available that are already RESTful. Does that make sense?
Yeah, it does. It's the thing we want to do. Just remember that when you go to a data source to bring data, there are kind of three issues you want to handle. One is how do you connect to the data source and bring in the data. Second thing is authentication. How do you make sure that the user has access to that data? And the third thing is the query language. We want to standardize the query language. So if you want to get only the first and 12th column from a data, and only the rows that have salary greater than 10,000, you'll specify it the same way on a Google Spreadsheet, or in a database, or in a CSV file, or in any other application, as long as it makes sense in that context. So this is why we didn't open it up yet just as a RESTful API. We want to add all those things together somehow in a good way.
Okay, thank you.
Go ahead.
How are people monetizing these gadgets, and what makes people like UPath want to make their commercial software available as a
So the question was, how do people monetize visualizations using this API? Yariv, Chris, do you guys want to answer the question? I mean, I'll let them speak. And
I can talk about Panorama, about our visualization. For now, we're giving it for you for free to play with and start working with. And of course, you can build a business model on top of it later of providing further analysis or further better capabilities on your own data. If you want to do deeper analysis, or if you want to really take it to the extreme, then you'll have to pay for it. I mean, that's in the future. But for now, it's just a free thing for you to work with.
A generalized answer for this would be, I mean, there's several models that you can look at. For example, you could see your visualization with companies like Panorama as a teaser, right? You give a low-level capability, and then you upsell into something that's much bigger and greater than that. And you could do an ad-based model. You could do a tiered sell where you have to log in and pay subscription price or whatever to get something with a larger feature set, etc. Go ahead.
Hi, I just wanted to add my +1 vote to the gentleman who came before on data sources, and I wanted to kind of follow up that question with another one. Can you be somewhat more specific as to the timeline as to when we might see alternate data source access?
So the question was, can we be more specific as to the timeline? We're kind of a quirky company in that sense. We find it very difficult to provide timelines looking ahead into the future and what we haven't launched yet. That's a high priority. So we've opened the JavaScript API. So I mean that significantly opens up the API beyond what was available up to the day before yesterday. And we did that in about less than 2 months. So hopefully we'll continue to execute as fast and get more things out there.
Looking forward to it. Thank you.
Go ahead.
I was just wondering if the directory of visualizations has any information about the performance characteristics. Like this chart can handle up to 1,000 items or something like that.
So the question, just to repeat, was does the gallery have information about performance characteristics of the visualizations? Go ahead.
We don't have it now, but I think it's a very good idea to add that, and we'll take care of that.
Thank you.
Just adding to the data sources. Right now, if I want to do my own data source, custom data source, does the API provide those capabilities, and how much effort is it?
So the question was, if I wanted to add my own custom data source, what does the API provide to do that? So right now what the API provides is basically the JavaScript flavor of the data source. We haven't opened up anything else on that end. Do you want to add
If you can
anything?
take your data from wherever it is and bring it to the client, then you can create from JavaScript a data table and push it into the data table class, and then use all the visualizations on top of that. So
right now, I'm looking at web services. That's my specific requirement. So can you give me a direction? My data is published as web services. So is there a quick way to publish my data using data visualizations?
I'm not sure I understand.
Yeah, I'm not sure. We didn't understand the question.
My data is right now published using web services. So I can make HTTP calls to get the data. So I think my custom data source would be web services custom data source. So does JavaScript you're talking about, does it allow to query web services?
No, you should query your web service the way that it works for your specific query mechanism and transfer mechanism. Get the data to the client, and from there on you can use our API to convert the data to our format.
Thank you.
Hi, I've actually been able to create a custom data source for the time series chart, and as a consumer of that, I've had some difficulty because I don't feel there's enough documentation on the data source required by time series, like what each column should be. There's an example, but I was wondering if there's ways I can extend it. Like right now, you can only have a bubble on the first time series line and not the second one. And before, it would only accept date and not date time, and those weren't documented anywhere. So I was wondering if there's plans for you guys to add that documentation for the end user, the consumer of the gadgets.
Yeah. So for the gadgets, you're right. We didn't have a strict documentation about exactly the expected data type. We expected every visualization developer to provide that in a free format, and some of them did, and some of them didn't. In the new visualization, the componentized visualization that you can put on any web page, there is a much more defined way how to describe your data format, your data policy, what happens with the data, and other categories of data. So if you look at the visualization gallery, you'll see that it has much more information right now, and we'll expect the same information from anybody who submits a visualization.
When was that updated? Because I was just looking at it like a couple minutes ago.
It was loaded last night, so it's fairly new.
Okay. I'll probably come talk to you.
Go to the website and check it out.
And if anyone has other questions that are more specific, we're having a booth now on the AJAX APIs, so you can come and ask questions or see demos.
And if you don't make it during the session, go ahead.
I looked through the gadgets, and I can definitely go ahead and make my own.
Can you speak up, please?
Sure. It seems like none of the current chart formats really take into account error bars on the data points, and I can definitely go ahead and make my own. But were you thinking about that at all in any of the ones that you've done?
So error handling in the different visualizations?
Sorry, not error handling. Error bars on the data points themselves.
So you want to put some kind of an indicator on the data point?
Yes.
Okay, so I don't know about a visualization that supports this right now. It sounds like a reasonable thing to ask for. It doesn't have to be error, any kind of an indicator on a point. The annotated line series chart actually supports something like that, annotations on values. So two things I can suggest is look at that visualization, and if you think you have a use case which is common, just go to our group and send us describe better what exactly you're looking for, what's your use case, and either we or maybe somebody else can pick it up and do that.
Okay. Well, one other request then is the flipping the axes. I noticed one chart flipped the axis on the X, but not on the Y. That would also be helpful.
So in the gadgets, we didn't have that option. In the visualizations that we launched now, there is the components for the line chart, bar chart, and the scatter. Yeah, there is a new option to reverse the axis. Yeah.
Thanks.
If I want to use the generic visualization API and someone publishes a gadget, is that component available through that just the vanilla visualization API?
So if someone publishes a gadget?
Yes. So they publish a gadget. It's got some like the Gantt chart. Is that available then also through just the standard visualization API?
Okay. So the way that We have a submit process on the website where you can, we encourage you to submit your visualization, whether it's gadget or JavaScript visualization. We'll look at it. If it doesn't have...
Someone would submit it to both, in essence. They publish it as a gadget and then submit it through what you're talking about.
The ideal case here that is somebody's going to develop a component of a visualization and then wrap it as a gadget with just less than 10 lines of code. Since we launched first gadget and only now we launched the component, then all of those who develop gadgets will need to do some kind of ripping out the core logic and making it a component. And this is kind of new, so it didn't happen yet. Okay. But this should be a very simple thing to do. So eventually, yes, everything will be either a component or a gadget.
Yes.
Will you be open sourcing your implementation like GWT, or will it just remain kind of a service API subject to your terms of service?
So are we going to integrate with GWT?
Open source your implementation, for example, how your query processor works against that language that you have, the visualization APIs that you already have, how you draw the 3D, pie charts and so forth.
So that's a good question. Are we going to open source this? There are thoughts about doing that, definitely. It's
Don't be evil.
Absolutely, absolutely. One of the things we need to take into account, I think it relates to an earlier question about we want to be able to create at least an initial set of generic capabilities so that everyone can use it and set something that makes sense and then open it up. So we'll try not to be evil.
I think our time is up. So if you have other questions, you can meet us outside.
One more thing. For those of you who've stayed, we've got some T-shirts. If you're interested, we'll take them out outside because we at the corner there, so we won't disturb the guys coming up for the next lecture. But if you want a T-shirt, please don't hound. Orderly line. Okay. Thank you so much.